Figure 1 shows a speed time graph of the car. Speed time graph. Okay, you can see the speed increases from 0 to 30. So that would be a constant speed. So you can see the speed is increasing from 0 to 30. So that means the car is accelerating, because speed divided by time will give us acceleration. So here we know that this will be constant speed. We know this is acceleration. And after 150 seconds, the car will start to decelerate. So this is what I know. So I'm just writing it on the graph before I look at the question. The graph in figure 1 is divided into 4 parts: P, Q, R, and S. Draw a line from the letter for each part to correct the description of the motion during that line. Going back to our graph, P as acceleration, Q as a constant speed of 30 meters per second, then R deceleration, S stationary, or it's not moving because the speed is 0. Okay, speed here is 0, so it's stationary. So that's what's happening at the 4 points. Let's go back to the question. So Q, like I said, the car is traveling at constant speed. P, the car is accelerating. R, the car is decelerating. S, the car is standing still. So that gives me my 2 marks. In 2 parts of the graph, in figure 1, the forces are balanced. State the letters of the 2 parts of the graph where the horizontal forces acting on the car are balanced. The horizontal forces acting on the car are balanced. That's horizontal. So where the car are balanced, that would be, the forces will be balanced if it is moving at a constant speed, and also if the car is stationary. So that would be Q and S. So parts Q and parts S, because Q is moving at a constant speed, S, the car is stationary or not moving, so forces are balanced. Calculate the distance traveled by the car in part Q. Distance traveled by the car. Let's bring back the graph. So this is our graph. Part Q. Distance traveled will be the area of the shaded portion. So what is this area? That will give me the distance traveled by the graph. So I can see from 50 to 150. So this is 100 and the height is 30. Or my distance traveled by the graph will be the length times the height. So that will be 100 times 30. So this will be 100 times 30. That gives me 3,000 meters. Okay, that gets me my 2 marks. A car with a mass of 1,800 kg is accelerating at 1.2 meters per second square. Calculate the force used to accelerate the car. Force is mass times acceleration. So my mass is 1800 kg. Acceleration is 1.2 meters per second squared. So force is 1800 times 1.2. This gets me 1 mark. My answer will be 2200. If I round that up, that gets me 1 mark. Figure 2 shows energy transfer diagram for a steam engine. The diagram shows the amount of energy transferred each second by the steam engine. Energy input 2000 joules. Useful energy output 160 joules. Wasted energy. So calculate the wasted energy. Calculate. I need to show my working out. My answer will be 1 mark. So total energy should be equal to useful energy plus wasted energy. That means 2000 should be equal to 160 joules plus X. So X will be 2000 joules. Take away 160 joules. That would give me 1840. Calculate the efficiency of the steam engine. Efficiency of the steam engine. We have the formula for efficiency. Useful energy here is 160 joules. Total energy is 2000 joules. Then times 100. Efficiency would be 8%, because this will be 0.08 times 100. So this steam engine is not very efficient. State what happens to the wasted energy. The wasted energy is always in form of heat, or we can say thermal energy. What happens to it? It is lost to the environment, or I can say surrounding. That gets me my 1 mark. Coal is a fossil fuel that is burnt in some steam engine. State 2 ways that the use of coal might be harmful to the environment. So when we burn fossil fuels, we always make CO2. CO2 is a greenhouse gas that contributes to global warming. So I can choose any effect that is harmful to the environment. I would say burning coal releases CO2, which is a greenhouse gas. Burning coal produces air pollution. I can also say burning coal, so incomplete combustion would produce carbon monoxide. That's very dangerous, carbon monoxide. Okay, so there are many things that I could say in this point, but it's 2 marks, so I go with this and this. A model train has a mass of 80 kg. It travels at the speed of 1.5 meters per second. Calculate the kinetic energy of the model train. So the formula is given to us here, so we don't need to remember that. And this is a 3 mark question. When it says calculate, I need to show working out, to show my working. So my mass is 8.0 kg. My speed is 1.5 meters per second. So kinetic energy would be half times 8 times 1.5. Now there's a squared here, so that will be 1.5 squared. So 1/2 times 8 times 2.25. My answer would be 9 joules. So where the mark? So if you did this squared, you get 1 mark. Now this working out, you get 1 mark. Then the answer gets us 1 mark. 3 marks. Use words from the box to complete the sentence below about ions. Atoms may form positive ions by, so how do we form ions that are positive? They have to lose electrons. The electrons involved in forming the positive ions are dash electrons. They have to be the outermost electrons. Okay, you can't lose the inside electrons before the outer electrons. Which of these radiation is both electromagnetic and ionizing? Beta, no. So alpha is ionizing, but it's not an electromagnetic radiation. Beta is not electromagnetic. Neutron is not. So gamma radiation is both electromagnetic and ionizing. So which type of radiation will travel the shortest distance in air? That would be alpha, because it has it's heavier, so it travels the shortest distance. Lead-214 is a radioactive isotope. State one way in which the radioactive isotope can be harmful to people. So this could cause cancer, or you can say radiation poisoning, you can say radiation sickness, you can say mutation, which is also referring to cancer, you can say damaged cells. So there's a lot of ways that radioactive isotopes can be harmful to people. Lead-214 emits beta particles. Describe what happens to the nucleus of a lead-214 atom when it emits a beta particle. Now, for 2 marks, it says describe, so I need to state facts, and I need to state 2 facts. Before I start stating those facts, I need to first write out the equation so I can describe. So I have lead is Pb, so 214, it's 214, when it loses a beta particle, so beta is 0 and minus 1, so that means the isotope here, or the new radiation forming here, will have 214 and an increased atomic number. So if it's increasing atomic number, radiation would have 83. So you can see that there's an increase in the atomic number. So my first fact will be an increase in the atomic number, or number of protons in the nucleus, because it says nucleus here. What other subatomic particle do we find in the nucleus? That would be a neutron. What's happening to the neutron? The neutron is staying the same. Neutron is not changing, as the mass numbers are still the same. So my second fact will be the number of neutron stays the same in the nucleus. Okay, so that's my 2 facts for my 2 marks. The typical size of an atom is 10 to the power of minus 10. The mass of a proton is 1.6726 times 10 to the power of minus 27 kilogram. The mass of electron is 9.1094 times 10 to the power of minus 31. So this is smaller. This is smaller, way smaller. Calculate how many times a proton, the mass of the proton is greater than the mass of the electron. So it's asking me how many electrons can fit inside the proton. So if it's fitting inside the proton, that means I have to divide by the mass of the electron. So that will be 9.1094 times 10 to the power minus 31, 6726 times 10 to the power minus 27. So that would give me 1836. Now it says give your answer in 2 sig figs. So 2 sig figs would be 1, 2. So I round that up to 1000, because these 2 numbers are not up to 50. Okay, that gets me, this gets me 1 mark, answer gets me 1 mark, my final answer gets me 1 mark for my 3 marks. Okay, and I've shown my working out because it says calculate. Okay, so this says calculate, show working out. So I've shown my working out, 1 mark, 1 mark, 1 mark. It's my final answer. Which of these would be a typical speed for a racing cyclist traveling down a steep straight slope? A steep straight slope would be this. Okay, so if you're going down, that means the speed would have to be a lot more. 0.2 meters per second, no, this is too slow. 2 meters per second, that is probably too slow. 20 meters per second, 20 meters per second is reasonable. 200 meters per second, that's way too fast. So yeah, I'll choose this as my best option for 1 mark. A cyclist travels down a slope. The top of the slope is 20 meters vertical above the bottom of the slope. So if I draw that again, top, bottom, this will be 20 meters. Okay, the mass of the cyclist is 75 kilogram. Calculate the change in GPE of the cyclist between the top and the bottom of the slope and take G to be 10. So GPE is mass times gravity times height. This equation you have to know. My mass is given to me as 75 kg. My gravity is given to me as 10. My height is given to me as 20 meters. 3 marks. Calculate. I need to show working out. So this gets me 1 mark so far. Then if I put that in my calculator, I would get 15000 joules. That gets me my final mark. Recalling this equation gets me 1 mark as well. An aircraft waits at the start of a runway. The aircraft accelerates from a speed of 0, so this would be my u, my initial speed, to a speed of 80, that's the final speed, v. The acceleration of the aircraft is 4 meters per second squared. Okay, calculate the distance x traveled. Okay, for 2 marks, the equation is given to me already. It says calculate, so I need to show working out. So x is, v is 80 squared minus 0 squared divided by 2 times acceleration is 4. Okay, this gets me 1 mark already. My answer would be x is equal to 800 meters. So I come to this line, I write 800 meters. That gets me my final mark. A student needs to measure the average speed of an accelerating trolley between 2 marks on a bench. Figure 3 shows the arrangement of some apparatus that the student used. So trolley, marks, string, second mark. Here there's a pulley here that we can attach our weight on. Okay, one piece of apparatus is missing from the diagram. This piece of apparatus is needed to determine the average speed. I know that speed is distance over time. Okay, state the extra piece of apparatus. I need to know the time. But from looking at the image, I can see the stopwatch is used already. So I'll leave distance. What do I use to measure distance? There's no meter rule here, so my answer would be they need a meter rule or a ruler. That gets me my 1 mark. Now describe how the students can make the trolley accelerate along the bench. For 2 marks, it says describe, so I need to state facts. I know that the student has to add or increase the weight or the mass. Okay, with the increase in weight, the trolley will accelerate even more. So my first point would be add weight on the string over the pulley. Okay, my second mark would be we can also put the trolley on a slope. Ideally, I've written 3 things here. So I've added the weight. Okay, add more weight. Okay, on the string, that gets me another mark. This is 1 mark, then this is 1 mark. So you can write any of the 2, that gets you 2 marks. The student wishes to develop the experiment to determine the acceleration of the trolley. State 1 other measurement that the student must make to determine the acceleration of the measurement. So to acceleration is v minus u divided by t. I know that. So the student needs the time between the 2 speeds. So the student needs speed at the start and speed at the second mark. Also, the student needs to measure the time it takes between the 2 marks, between the speeds. So any of this will get you 1 mark. Which color of visible light has the longest wavelength? I can remember my Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. This has long wavelength. This has a short wavelength or shorter wavelength. So out of the option, which has the longest wavelength, that would be red. So option red. That's 1 mark. Some television remote controls use infrared radiation. Other remote controls use radio wave. Explain why infrared remote controls may not switch on the television from behind an armchair, but radio wave remote control always will. Why infrared remote control may not from behind the armchair, which means that the armchair would absorb the infrared. That means that the armchair would absorb the infrared, but the radio wave can pass through it. Okay, so radio wave can go through the armchair. That's my 1 mark. This is because radio wave do not require a line of sight. I can also add that as my point. Radio waves diffract easily than infrared, so they can literally go over the armchair. So that's my 2 mark. I've given my point and I've given my reason because it says explain. Explain means to give a reason. Figure 4 is a diagram of a water wave. A cork is floating on the water. You can see height in centimeters, direction of wave. So that's yes, transverse wave. Peak. Okay, so wavelength here would be from 10, 11, 12. So my wavelength would be 12. Wavelength is 12 centimeters. Okay, that's my wavelength. So the question 1 is asking me exactly what I just did. Wavelength here would be 12 centimeters. Okay, because I've shown in my diagram distance from peak to peak is 12 centimeters. This is 1, 2, this is 3. This would be 15. 15 take away 3 gives us 12. Describe the motion of the cork, and for 2 marks says describe, so I need to state facts. If this is a transverse wave, which we know it is, that means that the cork is vibrating up and down. Okay, vibrating or moving up and down. Okay, perpendicular to the direction of wave. So I've described my movement of the cork. Moving on. A different water wave has a wavelength of 0.25 meters and a frequency of 1.5 hertz. Calculate the wave speed. Now, the equation that we need to remember, wave speed is wavelength times frequency. Okay, so wavelength is 0.25 meters, frequency is 1.5 hertz. This is 1 mark. My answer would be 0.38. Okay, that gets me my 2 marks, and I've shown my working out. Carbon 13 and carbon 14 are isotopes of carbon, which means that they have the same number of proton but different number of neutrons. So the question says, complete the table for an atom of carbon 13 and an atom of carbon 14. For 2 marks, complete means that we need to write our answer inside the boxes, not outside the boxes. So carbon 13 would have, neutron would be 13 minus 6, that would be 7. Carbon 14 would be 14 minus 6, that would be 8. Number of electrons is the same as number of protons, so this would be 6. Number of protons, 6. State the instruments that can be used to measure radioactivity. That would be a GM tube or Geiger-Müller counter. If you don't know the spelling of this, you just write GM tube or GM meter. Okay. State 2 sources of background radiation for 2 marks. 1 mark for this, 1 mark for this. That would be, one of them will be the sun. The sun has a background radiation. The ground, the rocks, ground has a background radiation. You can also say buildings, food, water, everything emits a radiation. Okay, so you have to account for them. So any of these points is good. Carbon-14 is radioactive and has a half-life of 5,700 years. The number of radioactive carbon-14 in a very old piece of wood is found to have decreased from 1 million to 125,000. Determine the age of the piece of wood. Okay, for 2 marks, we need to do some calculations. So let's go. It started from 1 million, and we know the half-life is 5,700 years. Okay, so if we half-life 5,700 years, so after that, this should come down to 500,000 because half of them would have decayed. So for another 5,700 years, this should come down to 250,000. So for another 5,700 years, this should halve, meaning we should have 125,000. So now there's been 3 half-lives. So we add 5700 plus 5700 plus 5700. That would give us 17,100 years. So this wood is 17,100 years. So we just will shoot our working out all through. In 1908, a scientist called Rutherford was investigating the idea about atoms. His students fired a beam of alpha particles at a thin piece of gold foil. So you can see beam of particles, gold foil. You can see that some bounced back, some went straight through, and some reflected or refracted. Okay, change in direction, refraction. So, okay, that's what we know so far. Some alpha particles were found at all parts of the ring detector. The table in figure 6 shows how many alpha particles were detected at P, at Q, and at R. At P, so like you can see from this diagram that most of them went straight through. So most went straight through, and some of them refracted, or we can say bent, and just 2 of them reflected. So they bounced back. Okay, the question says, explain what the information in figure 5 and figure 6 shows about the structure of an atom. Explain, give reason. 6 marks, so I need to have 3 points and 3 reasons each. 6 marks. So I'll start with my first reason. Most of the alpha particles went straight through. That's my first point. So my reason would be because the atom is mostly empty space. The atom is mostly empty space. Okay, so 1 mark for my reason. My next point would be some of the particles refracted. So they changed direction, or I'll say deflected. So some of the alpha particles deflected to Q, 1 mark, because the atom has a positive nucleus and the alpha particle is also positive. So opposites repel. So opposite charges will repel. My last point would be few alpha particles reflected or bounced back because the nucleus has a big mass. Remember, we have protons and neutrons in the nucleus, so the mass of the nucleus is heavier, so that will reflect the alpha particles. So that's my 6 mark answer. If you have found this video useful, please like and leave a comment. Subscribe and share with your friends. The aim of the video is to help you. Until next time.